Hello again. We are studying Calculus, Early Transcendentals by James Stewart, and we're on the topic of derivatives. And today we're going to talk about section 3.3, derivatives of trigonometric functions. We're first going to find the derivative of sine and cosine, and then to find the derivatives of the four other trigonometric functions, we're going to use the fundamental trig identities and the quotient rule for derivatives to derive those. Okay, in order to derive the derivative of sine and cosine, we need two special limits. And one we've already studied before, and that being the limit as x goes to 0 of sine x over x is equal to 1. You can either graph that function and see that it's a two-sided limit that is going to 1, or you can use the squeeze theorem like the proof before you does. And then we use that fact, the sine x over x, and some other algebraic manipulations that include multiplying by a special version of 1 down here, and also changing the 1 minus sine squared to sine squared, and then using some algebraic manipulations, and you see that limit as x goes to 0 of sine x over x. And so we can conclude here the limit as x goes to 0 of cosine x minus 1 over x is going to equal 0. So those two limits show up in the proof or the derivation of the derivative of sine x. Good, so and that is here. So we're going to find out that the derivative of sine x is cosine x, and by a very similar argument, you can do a very similar proof that the derivative of cosine is equal to minus sine x. Okay, we see that we are starting off with the limit definition of the derivative. So we'll have that the derivative of sine x is the limit as h goes to 0 of sine x plus h minus sine x over h. And we're just using the identity for the sine of sum of angles. Sine of a plus b is equal to sine a cosine b plus cosine b sine a. And cosine A, sine B, and we've got x and h here. So the sine of A plus h is just this quantity here. And then in the next step, we just rearrange terms. We're moving the minus sign in front of the plus cosine sine h. In the very next step, we want to factor out the common factor of sine x to end up with cosine h minus 1, and then we have plus cosine x sine h. Then in the very next step, we've got the sum in the numerator over the one denominator. We can split it up into a sum of fractions with the same denominator. And then in the next step, we're stating that the limit of a sum is the sum of the limits. And then in the next step, the limit of a product is the product of the limits. So we have a product here and a product here. And then again from above, remember that the limit as h goes to 0 of cosine h minus 1 over h does equal 0. And the limit as h goes to 0 of sine h over h does equal 1. And when we're taking the limit as h goes to 0, h is the variable in that operation. And so cosine x and sine x end up being constants in that limit operation. And so the limit of that constant is that constant. And then in that very second to last step, anything times 0 is 0, and anything times 1 is itself. So we end up with cosine. So we have that rule that if y is equal to sine x, y prime is equal to cosine x. And similarly, by a very similar argument, only using the sum formula for cosine of alpha plus beta would be used. Okay, so now that we have that, we can take derivatives, and we still have our derivative rules. The derivative of a constant is 0. The derivative of a sum is the sum of the derivatives. The derivatives of a difference is the difference of the derivatives, and the derivative of a constant times a function is a constant times the derivative of the function. And then if we have a product, we have to use the product rule. If we have a quotient, we have to use the quotient rule or manipulate the expression to be a product by maybe using some exponent rules, and then moving forward there. So, or other algebraic manipulations. All right, so here I see a difference, and I also see a constant times a function. So my y prime is going to be 3 times the derivative of sine, and the derivative of sine is cosine, and minus, and what's the derivative of x? The derivative of x is 1. So our y prime is just 3 cosine x minus 1. The next one, we don't have the chain rule yet. Otherwise, we could use this using the chain rule. This is asking us to find the second derivative of sine squared, and we know that sine squared is the same as sine x times sine x, and that is a product, and that is going to be y f times g. And so we know that our y prime is going to be the derivative of the first times the second, plus the first times the derivative of the second. And so here we go. The derivative of sine is cosine, times the second, which is just sine, plus the first, which is just sine x, and times the derivative of the second, which is cosine x. Right? And a times b equals b times a. So cosine sine does equal sine cosine. So those are like terms, and we can combine them to say that this is equal to 2 cosine x sine x for our y prime. Again, we have a product. So we have f times a g. And so our y double prime is going to be the derivative of the first times the second, plus the first times the derivative of the second. And the derivative of the first, what's the derivative of 2 cosine x? That's constant times the derivative of that function, 2 times minus sine. So that's going to give me minus 2 sine x. Times the second is sine x. Plus the first is 2 cosine x. And the derivative of the second, the derivative of sine x is cosine x. So we have, and if we swap spots, we would get the minus 2 sine squared x. So we can rearrange this to say that this is 2 cosine squared x minus 2 sine squared x. And you can use trig identities, factor out the 2 and do trig identities if you'd like, or you can leave it as is. And to save time, I'm going to leave it as is. I believe that would be a cosine 2 theta. Okay. How would we find f prime if f of x is x e to the x cosine x? And we have a product of 3 functions here. I tend to just split 2 of them up. I'll combine 2 of them to say that that's my f, and then the second one is my g. And over here, just to be clear, I might build a table, and if my f is equal to x e to the x, my f prime is going to be the derivative of the first, which is 1, times the second, which is e to the x, plus the first times the derivative of the second. And so I see here that f prime is going to be 1 plus x times e to the x. G is cosine x, and our g prime is going to be minus sine x. So now my f prime is going to be the derivative of the first times the second, plus the first times the derivative of the second. And what's my first? The derivative of the first is 1 plus x times e to the x. The second is cosine x, plus the first is x e to the x, and the derivative of the second is minus sine x. And now we might want to clean things up, and I see that there is a common factor still of e to the x, so I can factor that out, and I'm going to get 1 plus x cosine x, and then I'll have minus x sine x, and you can leave it like that. Okay, so that can handle the product of more than 2 functions. Just group 2 functions together and take the product rule for that one when you're so it's kind of like doing the product rule within the product rule. Okay. Here, how are we going to find, so here is an example of, we're not going to be freaked out over finding equations of tangent lines that involve complex functions. It's about recognizing what type of derivative to take. Am I looking at a product? Am I looking at a sum? Am I looking at a constant times a function? And when we get to the chain rule, am I looking at a composition of functions? So here I see we don't have the chain rule yet, so we don't have a derivative for e to the minus x yet. But what we can do is rewrite our f of x equal to sine x over e to the x, and we can call that our derivative of a quotient, right? So if we call that y, this is going to be our f over g. And so our y prime is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And I can plug in my values. So the derivative of sine x, that's the derivative of the top, that's going to be cosine, times the bottom, minus the top, that's going to be sine x, times the derivative of the bottom, and the derivative of the bottom is still e to the x, all over e to the x squared. I can factor out an e to the x and cancel one of them, even though you don't have to. If we're just going to find the equation of a line, we can keep it in that form and just go ahead and evaluate the derivative there. But just in case you needed to actually find the derivative function, it's nice to simplify things. And we've got 2 e to the x's down below, 1 on top, and 1 can cancel to leave 1 left over, so that we have y prime is cosine x minus sine x over e to the x. Good. So that's our derivative, and that's going to give us our slope function. So remember how to find the equation of a tangent line. We have first, step 1, find your point on your curve. So sometimes you only have x, and you need to find your associative y. But in this case, we have 0, 0, and that's going to be our x1, y1 for our tangent line. Our slope is going to be f prime evaluated at 0, because we want to evaluate it at our value of x. And so we've got our slope function here, so that's going to be cosine of 0 minus sine of 0 over e to the 0. Cosine of 0 is 1, sine 0 is 0, and e to the 0 is 1. So we have that our derivative is equal to 1, and that is our slope. The slope m is f prime evaluated at 0, and it's going to give us 1. And finally, we put our equation together, our tangent line. We have a point, we have a slope, we use our point slope form, and we're using a y minus y1 equal to m times x minus x1, and we plug in our values, and we've got values of 0 and 0 here, and our slope is 1, and so we see that y here is just going to equal x. That's a pretty nice mx plus b, nice 45-degree angle. Good. All right, so that's just working with some, the sine and cosine and various product and quotient derivative rules. And now we're going to derive the derivatives of the remaining trigonometric functions. We remember that secant is 1 over cosine. And so if we use the quotient rule, as you see here, and then followed by that we simplify, and then we start using algebraic manipulations, and we're using fundamental trig identities. 1 over cosine is secant, sine over cosine is tangent, and so now we have the derivative of secant is secant tangent. Okay, again, when we derive tangent, we use the fundamental trig identity sine over cosine. We use the quotient rule again. We know we're using a fundamental trig identity, cosine squared plus sine squared does equal 1. And 1 over cosine squared is 1 over cosine times 1 over cosine, which is secant times secant, and that's secant squared. Good. Notice on the other side, and I do want to notice here just to put down here, sine, the derivative with respect to x of sine x is cosine x, and the derivative with respect to x of cosine x is minus sine x. And notice the 6 trigonometric functions, we've got 2 lists. We've got sine, tangent, and secant, and then their co-functions. They're 90-degree cousins, right? Co stands for complementary, and complementary is a plus b equal to 90, and those a's and b's are your angles. So we've got secant and cosecant. Those are co-functions of each other. We have tangent and cotangent. Those are co-functions of each other. And sine and cosine, they're co-functions of each other. And remember, it's sine of theta is going to equal cosine of 90 minus theta. And that's where that relationship comes into play. But notice their derivatives. The derivative of secant, tangent, and sine have all positive derivatives, and the derivatives of the co-functions are all negative derivatives. On top of that, the derivative of secant tangent, you've got the derivative of cosecant is minus cosecant cotangent, so it's the negative of the co-functions from secant. Same thing goes for tangent. The derivative of tangent is secant squared. Well, the derivative of cotangent is going to be minus cosecant squared. Do you see the connection? And the same thing goes for sine and cosine. The derivative of sine is cosine. That means the derivative of cosine is going to be minus sine. It's co-function. So I point that out so that people are motivated to memorize all of the derivatives of trigonometric functions. It's very useful in future studies within calculus to just be ready to go with what the derivatives of the trig functions are. And so if you just memorize 3 of them, you can get the other 3 by knowing that trick. Good. All right. So we'll stop here because we just don't need to do that. All right. I will talk to you guys again with the chain rule, and we will be using a lot of the trig functions with the chain rule, and that's coming up next. Take care.